Welcome guys, we have a 2007 Toyota Corolla. It's a 4-cylinder petrol engine. Customer's complaint is just very rough idle. I'll just quickly start the car and let's see what customer's complaining about. Yeah guys, as you could see, probably you could hear on the camera that it is definitely rough idle. The car is running at the moment. I can feel there's kind of like a misfire, not really a misfire but very rough idle, and it was really difficult to start after the first attempt. And once the car started, I could smell a lot of fuel from the exhaust, and I can see a lot of smoke from the exhaust as well. When I rev it hard, it's good, and I did take it for a drive earlier. It drives good. Okay, plenty of power on a straight road, but as soon as it come down to idle, very rough. So usually a couple of things I can think of when this happens. One's obviously is a vacuum leak that can give you a rough idle, and when you rev it, it's good. And second thing I can think of is maybe engine mechanical issue, like a compression issue. That can also give you that similar sort of scenario most of the time, rough idle, and when you rev it, it's good. Okay, let's go under the hood and let's see what we can figure out. I'm under the hood now. I can definitely feel that engine sort of shaking a bit. It's not bad. I don't think it's like a misfire. It's some kind of hesitation there, and I don't really hear any vacuum leak. But before, when I was trying to start, I already didn't like the sound of the engine. You know, it's not consistent. So I'm already thinking it does have that mechanical issue. So I'll probably gonna go straight to that, but if that's not the case, I'll probably come back to do the intake leak test or something like that, smoke test. But the way the engine cranked, I didn't like it, so I'm gonna just do a compression test real quick. Alright, you guys seen me do this before. I'm just gonna do a quick compression test using my Oscilloscope. Just positive, negative on the battery. And what I've done is I just took out all my ignition coil plugs so the car won't start. So we're just gonna crank it. So here on the screen, we're just gonna use Pico's diagnostics. And we're gonna go compression test, 4-cylinder engine, start, and okay, I'm just gonna crank the engine quickly. All right, so we got two bad cylinders here, 82 and 86% compression. Now this compression test only gonna give you sort of like a compression analysis overall. It's not gonna tell me which cylinder is bad. So we know there's some kind of compression issue. We can hear it in the startup noise, and also we can see it on the scope here on the screen. So definitely this 2-cylinder. Now we gotta figure it out which cylinder is at fault. So what I'm gonna do, I'm gonna close this page. I'm gonna go back to Pico Diagnostic. Now I'm gonna use my channel 1, right? And I'm gonna use this to sync it with number 1 cylinder. So now I'm looking at it here. I'm just trying to identify which is my control wiring. So let me just grab a light and I'll zoom you in there so you can see what I'm doing. All right, so this is a 4 wires design. So usually you'll have 3 same color wire and 1 different color wire on each plug. That is going to be your control. So this is coilover plug, so transistor is in the coil itself. So computer is going to send sort of like a 0.5 or 0.12, something like that, depending on the car, signal to turn this coil on and off. So if you look closely here, this one has red, yellow, white with a something, and a last one here is a white with the black. So if you look at the next one here, red, yellow, black, and a white with a black. So see in these two, this number 3 wire, this is black, and on this one this is white. So that's a different color wire. If you follow that to next cylinder, see the number 3 wire is green, and the last one you'll have a kind of like a black here. So this one was also black, but anyway, you got the point. So I got green, black, black, and a white on this one. So we know that's our signal wire. So I'm just gonna take the sync for number 1 so we can recognize which cylinder is at fault, which giving us low compression. Okay, so I'm gonna just back probe on that white wire, the 3rd one, on number 1 coil, while the plugs, all the plugs are unplugged. Okay, just my channel 1 on that 3rd wire. Just back probe that. My ground is still connected to the battery, negative. Okay, now I'm gonna get my amp clamp made by Pico. I'm gonna go 2000 amps. Okay, and I'm gonna connect that to channel B. So I'm just gonna go and connect that to maybe negative, doesn't matter, positive, negative. I'm just gonna connect that there, 0 my amp clamp. First channel, so first channel I'll probably go plus minus 20, doesn't really matter. Second channel we selected 2000 amps on a 2000 amp clamp right there, and we'll probably go, I don't know, plus minus 200 should be enough for this engine. I don't think they consume a lot of amp, so I'm gonna change my time base here. Let's go 1 second. I'll just move that down. Let me quickly start the car and let's see if we have the amp clamp right. Sometimes it can be inverted and we have to change the polarity. Yeah, now that's definitely going the right way, so we know it's good. So we'll just 0 that amp clamp again. Right, just 0 that amp clamp. I'm selected 2000. Now what I want to do, I want to quickly crank the engine, and that's going to give me show me which cylinder is at fault. Okay guys, all right, that's enough. Let's go back to the screen here. Now I'll just pause that. Let's go back 1 page. So I'll just zoom right in there somewhere. Let's take 2 or 3. Okay, now from here to here is, I'm sorry, I'll have to go back something. So from here to here is my 4-cylinder compression. So as you can follow up there, you got 1, 2, 3, 4 cylinder back to 1. So on this engine, I know from memory the firing order is 1, 3, 4, 2. Okay, So this is my number 1 compression, 3 compression, number 4 compression, number 2 compression. So look back to 1. Looks like number 2 and number 1 is low compression. You can see right there. I'll just pull that down. See that this number 1 and number 2 is lower than this other number 3 and 4, and the cycle repeats. You can see here, same thing, number 1 and number 2, right here to number 1 and number 2. So we know number 1 and number 2 was the one we're seeing low compression. I want to figure out where is this compression leaking. Is it our compression ring? Is it our piston damage, cylinder wall damage? You know, head gasket leaking, valves are leaking, intake, exhaust valve. There's a lot of places the compression can lose, the engine can lose compression. So we're gonna do some pressure analysis here to try to figure out where is this compression going. All right, next test I want to do is maybe let's do a head gasket, maybe a blow-by, and maybe intake. We can do it right here. For the exhaust I need to go to the back on the tailpipe. So let's just do what we can do here quickly. All right, for this test I'm just gonna use my pressure delta pressure sensor or first look sensor to do this test. So I'm just gonna go loop around up here, okay, and then just connect that to my channel 3. At this point I don't think we need the channel 2, the battery amp clamp. We already know number 1 and number 2 is at fault, okay, so I might get rid of that, but we'll just leave that there for now anyway. But I'll turn it off here on the scope, okay. Now so first thing I want to do, I want to quickly do the head gasket leak test. So it's right there. I'll just show you what I'm doing. I'm just gonna put my pressure scope little attachment here for the pressure sensor. Take the radiator cap off. Right, I'm just gonna stick that in the radiator like that. Okay, then I'm gonna go and crank the engine. I'm just gonna turn my channel 3 on real quick. Maybe let's go plus minus 500 volts. Okay. All right, I'm gonna go crank the engine now. Yeah, I don't see anything there. Maybe let me change that voltage level a little bit down. Okay, let me try again. Pause that. Let's analyze that data real quick. Let's go back to the page. Let me just zoom maybe 2 here. And on that green channel, you can see our pressure on the radiator is flat line. There's no pressure rise, so we know the compression is not leaking into our radiator. So let's move on to the next test. Next test I want to do is see if our intake, not intake, sorry, see if it's leaking into the blow-by, into the engine itself. So we're gonna just take the dipstick out. We already did that, and we're gonna put our pressure reading, pressure pulse sensor right here. All right, I'm just gonna stick that in the dipstick hole like that, and I'm gonna get a reading while I'm cranking the engine. Same thing, we haven't changed anything on the settings on the scope, so I'm just gonna crank the engine now. I think that's a little bit too much 2 less voltage there. So let me just go a little bit more, maybe let's go 1 volt. Let me try that. That's a little bit too much. Again, let me just go 5 volt. That's all right. All right, cranking it again. All right, we capture that data. We pause that. Let's go back to the page again. We collected our data. So let's just, you know, maybe select 3. All right, as you can see here, that's our number 1 right there. That's our number 1 firing again. So between here and here, we got 4, 1, 2, 3, 4 push from the blow by, and all of them look pretty similar. Okay, at the top, there's not much really difference there, and at the bottom, same thing, not much difference there. So I don't think the compression is leaking into the combustion into the the crankcase. So I don't see a problem there. So let's move on to our next test. So we can put our dipstick back in the hole. So the next test I want to do is an intake pressure reading. Okay. So all I'm gonna do, I'm just gonna take this hose off. Let me just, let's just take this hose that's in the intake manifold. That's the easiest place I can see. And I'm gonna put my pressure sensor in that hole. Okay, so now we are reading intake manifold pressure. Okay, same thing again. Let's go back and let's restart this picoscope. Now we'll leave it to 5 volt. Let's see what sort of waveform we get. All right, now I'm gonna crank the engine. All right, we pause that. That's a good capture there. And let's go back to that page. All right, I'll just move this out the way real quick. All right, let me zoom maybe 1, 2, oops, that's too much. Let me zoom maybe 1, 2, 3 maybe. Okay, now definitely there's something going on here, as you can see. So between here and here, like I said, 720 degree, and if you follow that down, you need to see 4 equal vacuum pull, okay, on the pressure sensor. And we are seeing that there's 1, there's 2, there's 3, there's back 4, and there's back to 1. So we are seeing 4 pretty even pull, I would say. There's not much different there, to be honest. On that green channel, I have a look here. So we got 1, 2, 3, 4, back to 1. So we got 4 even pull. So intake, the engine, all the engines are intaking good. I don't see a problem. But if you look on the rising side, there's 1, 2, 3 is pretty even. Maybe even this one here is a little bit higher than the other 2, but I'm not too concerned about it. But definitely this one looks much higher. Okay, now definitely there's a problem here, guys. I'll come back to this. I will do a quick exhaust pressure analysis as well, and then I'll come back to this if there is a problem in the exhaust or not. Sometimes you could have problem in the exhaust and intake at the same time. So I don't want to spend too much time just yet. I want to go to the exhaust. So next step, we're gonna do our exhaust pressure diagnosis. So for that one, I'm gonna have to get a longer lead because the exhaust is at the back. So let me go quickly grab that. I'm just gonna use the same pressure sensor, just with the longer lead, and I'm gonna use channel 4. And I'm gonna go back to the exhaust. I'm just gonna put this in the tailpipe, just like that. Stick that in the tailpipe, and then we'll get a pressure reading for this one. Alright, just let me turn on my channel 4. Let's just go plus minus 2 volt maybe. Alright, I'm just gonna crank the engine again. Alright, let's pause that. And let's go back and do the same thing. We'll just maybe take a couple of these. Let me just rescale that a little bit less. Okay. Now again, let's see what we can. So from here to here is our one full cycle of the engine. So on the exhaust, we got good exhaust pull, 1, 2, 3, 4, and on the higher rising side on the pressure, it's also 1, 2, 3, 4. They're all looking even, guys. I don't see much. There's obviously a little bit of difference there, but we know there's a problem with the compression, so it's obviously going to give you that little bit of difference characteristics in the waveform, but I don't see a huge rise in the pressure or vacuum here. So I'm pretty confident there's nothing wrong with the exhaust valve. Okay, so let's go back to the intake where we said there was a problem. All right, let's get that capture one more time, and then we will do some analysis here. We'll go back to plus minus 5 volt again. I'm going to crank the engine again. All right, let's go back here and we'll zoom that, maybe just get maybe 2 or 3. All right, that's what we got here, guys. I'll just move that up, move that down a bit. Okay. Now what I want to do is I want to quickly pull up the piston chart right here. It is a great tool, guys. Everyone should have this. I think it's like 18 or 20 US dollar. You can buy it online. And we know the firing order is 1342. We'll sync it to number 1, and we go on, and this will pop up. Now we can sync this to where we want to sync. All right. So right here. Okay, I'll move that down a bit so we can see it a little bit better. Anyhow, that's close enough. Now what I also want to do is I want to just rescale that down a bit. Okay, so what I want to do, I want to just bring out some rulers. 1, 2, 3, 4 partitions. Okay, and we're going to put that to 720 degree. You can see down here 720 degree, and I'm going to bring that to about there. That's 0 degrees. So this will give me 4 partitions, and this chart will show me exactly what cylinders are doing what at what time, if you know what I mean. So just helps you with analyzing waveform data like this. So now we need to know why there is this big spike on our intake manifold. Okay, so let me just quickly see what's going on here. Then when I know something, I will talk to you guys. Okay, so we got 1, 2, 3, 4 good vacuum pull, so we know there's nothing wrong with the intaking of the cylinders. And when it's finished its intake, it rebounds up and this next cylinder's intake open. So right here, this the intake for number 4 cylinder, if you can follow me. So this is where the intake for number 4 starts. That's the intake full for number 4, that's the intake full for number 2, that's the intake full of number 1, and that's the intake full for number 3. Now we have already verified before that our problem is on number 1 and number 2 cylinder, right? So honestly speaking, it's a little bit complicated because there's only one significant difference on this waveform. Rest 3 looks good, but we said we have 2 cylinder that is at fault. We should see some kind of, you know, I would expect some kind of difference, 2 different waveform, intake manifold, pressure 2, but I'm not seeing that right here. So to me, it's definitely a difficult one to analyze. Okay, so intake is good, rebound is good. Then let's analyze. So number 1 is just finishes, starts its intake right here. Just follow my cursors here, guys, and then it comes down. Then it comes down on intake right here. Intake for number 1, intake for number 1 finishes here. Then the sensor will try to rebound up. I would say that's what's happening. And the pressure equalizes right here. And then it should really be getting ready to open the intake for number 3. And if it's a running good engine, I would expect to see this line sort of goes this way, equalizes it, and then come down on intake right here like that. Okay, but obviously right here when it's supposed to come down on number 3, it pushes up more. So there's some kind of pressure is leaking into the intake from somewhere right here. And we know number 3 intake is opening around there where the pressure rises, but we know number 3 intake is not at fault because number 3 compression is good. Number 1 and number 2 is bad, so it can't be number 3, right? So that's out of the question. So let's see what other cylinders are doing. So number 4 is on exhaust, intake valve is shut. But if the number 2 is on power stroke, both valves closed, piston coming down. Number 1 is our faulty cylinder, and number 1 should be the one pushing the air into the intake, right? Because number 3 is good, number 4 cylinder is good, and number 2 is bad, but number 2 is coming down on power stroke, so that doesn't make sense why you would push intake on power stroke. I would say you would do it on compression stroke. So I'm still focusing on number 1 here, guys. So Okay, I think I know what I'm looking at here, so I'll try to describe to you guys what I'm seeing, what I think is happening. Okay, so in my opinion, and what I can gather here is number 2, this pressure rise you're seeing is because of the number 2 compression. Okay, now hear me out. Okay, number 1 intake is number 1 cylinder is open on intake, right? Now number 2 at the same time is going up on compression. So when it hits about halfway to more than halfway, maybe right around here, compression stroke, piston is traveling up, it's pushing the compression air into the number 1 cylinder, and number 1 cylinder is pushing that air into the intake of number 1, from the number 1 intake valve to the intake manifold. Did you understand what I'm trying to say? Okay, I'll try again. Number 2 is coming up on compression, pushing the air into the number 1 cylinder, and number 1 intake valve is open at the same time. That's why we have pressure rise up here, because of that reason. So to me it looks like there is a leak between number 1 and number 2 cylinder. Okay, that's all I can see here. That's the only thing I can think of, because everything else does not make sense at all. It is possible number 2 could be, no, that's not possible. I'm thinking maybe number 2 intake valve is bad, but I don't think that's very possible here looking at this waveform. So I'm pretty sure that's what's happening. Number 2 is pushing the air compression into the number 1, and number 1 intake is open at that time. That's why you see this big rise on green channel here on the intake manifold. Now you can say, why is it not, why aren't we seeing same thing? Because there is a leak between number 1 and 2. That means number 1 could also push compression to number 2, and why we're not seeing it. And I can explain to you why I'm not seeing that is because when number 1 is going up on compression, look what number 2 is doing. Number 2 is on power stroke. Can you see that? So number 2 is on power stroke. Means both valves will close. Okay, so number 1 is pushing gas into the number 2 cylinder when number 1 is on compression. When number 1 is on compression, is pushing gas to the number 2 piston cylinder, but number 2 is on power stroke coming down. Okay, so both valves open. That's why we're not seeing that activity on the intake manifold pressure. That's what I can see. That's why we're only seeing that effect on intake only on number 1 leaking to number 2 scenario, not the other way around. No, sorry, number 2 leaking to number 1, not the other way around. I know it's a little bit complicated to understand. Maybe I'm having difficulty trying to explain, but that's what it looks like, guys. And if you really want to talk about this little bit of pressure rise here compared to this number 3 and number 4 cylinder, this is for number 2 intake. Number 2 intake is about to begin here. So what I'm thinking here is, this is only maybe, I don't know. I'll have to spend a bit more time thinking about it, trying to figure it out. But what I'm also thinking is, right here when number 1 is going up on exhaust stroke, obviously exhaust valve is open, but we know there's a leak between 1 and 2. Maybe it's possible that number 1 is pushing air into the number 2, the exhaust gas on exhaust stroke, and number 2 is intaking. Maybe that's why we see a little bit of pressure rise here, because it's also, number 1 is also pushing that exhaust gas into the number 2 and number 2 intake is open. Maybe a little bit pressurized, that is very possible. But I'm not too worried about this one. I'm only focusing on here, and that's what it looks like. There's a leak between number 1 and number 2 piston through the, I would say, head gasket, possibly. Okay. All right, I'm gonna take this number 1 and number 2 spark plugs out. One spark plugs out, start number 2. It's number 2 out. Smells very fuel in that spark plugs. Obviously we got low compression. Fuel's not gonna burn as efficiently. So next step I want to use is my cylinder leak down tester. So I'm just going to screw that adapter in the hole. And I'm going to reach down on the harmonic balancer, and I'm going to turn the harmonic balancer, bring it to the compression number 1 stroke. Okay, make sure you turn the key off when you do this. We don't want this engine to accidentally fire on us. So definitely something to consider whenever you're doing this type of testing. So I'm just going to reach down there on the harmonic balancer, and I'm going to turn that balancer, and I'm going to bring it to the compression stroke. Alright, that should be our number 1 compression. So what we're going to do, we're going to put some air down there. Alright, I'm just going to attach the air. And I don't know if you can hear it, but on number 2, I got massive leak from number 2 spark plug hole. So what that means is we got a leak between number 1 and number 2. Okay, let me just quickly see if I got anything on the intake. I don't feel anything on intake. Let me go and see if anything on the exhaust. And I got nothing on exhaust tailpipe as well. So definitely that's our problem, guys. I hope you can hear that. So the problem is cylinder head, cylinder gasket leaking between number 1 and number 2 cylinder. All right, this needs a new a head repair. I'll end this video right here. Hope you guys learned something. I'll catch you next time.